Hi, we're looking at 3.1 today. As soon as we're done here, you can go ahead and start this assignment on page 150. So, a couple of vocab words that you'll recognize, a couple of new ones here. First off, parallel lines. Parallel lines are coplanar and they don't touch. Okay? They do not intersect. The reason that we also need them to be coplanar when typically we just kind of say two lines that don't touch is because we're going to add a word in here today which is skew. And skew is going to be a very similar example here. Don't touch. All right, but they are non-coplanar. And if we get into some examples, you'll definitely see the difference between parallel lines and skew lines. All right, and then of course we've got perpendicular lines. And that is 90 degrees. All right, they meet at a 90-degree angle. So let's look at our first example. It says, think of each segment in the diagram as part of a line. So imagine it goes forever. Complete the statement with parallel, skew, or perpendicular. And we're just going to assume, because we don't want to have to draw all of these things in here, we're going to assume that every single corner is a 90-degree corner. So it's a perfect rectangle prism. So let's take a look at our first one. WZ, that's this top one right here, and ZR, that's this one going up and down here. And our three choices are parallel, skew, or perpendicular. They intersect. We don't know for sure they intersected at 90, but we're going to assume that they do. And so these two are perpendicular. All right, there's number one. WZ, same first segment here. We're going to assume it's a line. And ST. Okay, so here's where we have to talk about the difference between parallel and skew. Could you draw a plane that contains these two? And I think that you could. If you imagine a line, a plane going diagonal through here, this way, up through here, and so on, you could make a plane that contains both of those. And so this one is in fact parallel. All right, let's look at an example of one that is not. So here we've got QT, which is going front to back, line going that way, and YS. And it just wouldn't be fair to call these two things parallel, even though they don't touch. And this really only works in the 3 dimensions. In 2 dimensions, it's either going to be parallel or they're going to intersect. But when you add a 3rd dimension, these two lines, though they continue forever, would never actually touch. But is it fair to call them parallel? And the answer is no. There is not a single plane, even if you draw in this plane doesn't contain that line. So this line straight up and down hits it, but it doesn't contain it. It's not on it. And so it's not fair to call that parallel, and so the only word left we have is skew. Now, planes are only going to be parallel or perpendicular. Planes cannot be skew because either they're never going to touch and they're parallel, or they're going to touch, because planes go forever in 2 directions, while lines kind of only go in opposite directions, whereas a plane goes forever that way, that way, that way, and that way. So kind of almost 4 opposite directions there. So let's take a look at the first 2 examples here. Plane WZR, so 3 letters here. WZR is the front plane. We'll highlight that one red. SYZ is the side plane right here. These two intersect at that exact point, and so they are perpendicular. RQT is the bottom plane YXW is the top plane. These two planes, even though these two planes will go forever in kind of all four directions, it doesn't matter. They will never touch. And so they are parallel. All right, we're going to go ahead and move on to a next set of vocabulary words. Transversal, alternate interior angles, alternate exterior angles, consecutive interior angles, and corresponding angles. So we will come back through and we will put these into our yellow packet. But for now, I just want to kind of go through some examples, starting getting a feel for it. You can know the definitions, but it's really about a visual. So seeing them and understanding kind of the pattern or how we describe them. So corresponding angles. There are actually 4 corresponding angles in this picture right here. So let's talk about what's happening in these pictures. These are just 2 random lines right here. Okay, they're 2 lines and they just happen to be crossed by this line right here. And this line we call a transversal. It's basically a line that intersects 2 lines. All right, so we've got a transversal. It's a line that crashes into 2 other lines. And why that's important is because there are angles created, like angles 1, 2, 3, 4, and 5, 6, 7, 8. Now, we already have names for the angle pairs, angle relationships that are all within one line. So if we just zoom in on this one, we already know that angles 1 and 2, we call that a linear pair. We call angles 2 and 3 across from each other, we call those vertical angles. So we already have names for all of these things. We are now going to name the things that happen over here. How do they match up to the things that happen over here? So for these examples, we are always going to match one from here and one from there. And we have 4 ways to describe them. Corresponding angles, there are 4 of them. Describe angles that are in the same position. Same position. So correspond, they're in the same position. That would include angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. So we're always talking about the same spot, kind of the upper left corner, upper right corner, bottom right, all those things. They all correspond to each other. All right, they all correspond to each other. Make some room for our other angle types. The rest of them, there are not as many because we've added in some words here. Interior, exterior, and then interior again. The stuff in between these angles here, we call these interior because they are in between the 2 lines. These angles on the outside are considered exterior. They are on the outside of your 2 lines. So interior is 2, 4, 5, and 7. Exterior 1, 3, 6, and 8. So what would be an example of an alternate interior? Well, alternate interior angles pick ones that are interior, but they alternate from each other. So they are on alternate sides of the transversal. It would be angle 2 and angle 7, as well as angle 4 and angle 5. So they alternate, they jump over the interior transversal part. Alternate exterior just simply means same idea, jumps over the transversal, but they're on the exterior. So what would be the alternate exterior pair with angle 1? Well, starts over on the top side, you would jump to the bottom side, that would be angle 8. Angle 3 would match up with angle 6. So again, it's important to recognize interior, in between the lines, and exterior, outside the lines. Corresponding actually doesn't have that word because you have one of each. For example, angle 1 is on the exterior and angle 5 is on the interior. So corresponding, you're going to have one of each. All the other ones have a specific name next to them, and that name will tell you where to find those angles. All right, finally, the last one, consecutive. Interior. Consecutive interior, again, is going to be interior, but it's the opposite of alternate. It's on the same side. Consecutive, they're next to each other. So angle 2 and angle 5. Or 4 and 7. So these have some special relationships when the lines are in certain patterns, but for now we're just trying to name them. We're going to recognize what they are, and then we'll talk about kind of what the special patterns are when we have certain types of lines. So let's just spend the next couple practicing naming these things. It's good to start kind of identifying where your lines, where your transversals. So this is my line, and here's my line. My transversal runs this way. This would be my interior. And this would be my exterior. These are all kind of tools that will help you name these things once you get going. So now we look at this and I say 1 is on the exterior, but 5 is on the interior. So there's only one choice left here, and it's got to be corresponding. These two, angle 1 and angle 5, angle 1 and angle 5 are corresponding angles. Corresponding angles. They're in the same position, kind of the upper left side of the intersection. And remember, in these situations, we're always going from one intersection to another intersection, not within the same intersection. All right, let's do it for the next one. Here again, I'll highlight my line, my two lines here. My transversal crosses those two lines right there. There's my transversal. I will identify my inside again. My interior is in the green. My exterior in, let's do that in pink. So angle 2 and angle 7 are both exterior angles. Angle 2 and angle 7 are both exterior angles, and they are on alternate sides. The only choice we have for exterior is alternate exterior. And so I can say with certainty here, angle 2 and angle 7 are alternate exterior. angles. All right, finally, let's do this last one a little bit quicker here. So I recognize that my lines are here. My transversal comes up along. These are my interior angles here. My exteriors, I'll put them on the outside and the outside here. Of course, I don't really need to label my exteriors because I see 5 and 4. Now, the only question would be, are they consecutive interior or do they cross over? And these two jump over, and so 5 and 4 are alternate interior angles. All right, there's just one last example before we break for you to give the homework a try. I want to show you one of these, and we'll come back on the next class time and work through the rest of these together. But let's talk about angle 1 and what else corresponds with angle 1. So let me highlight this green here. Now, we're not going to use any of these other angles right here, because none of these words describe angles next to or touching angle 1. You've got linear pairs, you've got vertical angles to describe those things. But what other lines via transversals create corresponding parts? So let's take a look. What if we mark this one as our first line and this one as our second line? Now let's just ignore what's happening over here. So I'm going to kind of just cover that up, and you could cover it up with your hand. I'm going to ignore what's happening down here, and I'm going to ignore what's happening right there. I'm just going to look from kind of this upper left corner, the group that is 1, 2, 3, 4, and I'm going to match it up and find one that corresponds with group 11, 9, 10, and 12. So if one is kind of above the line to the left of the transversal, then if I go above the line to the left of the transversal, it must be 11. And so for question A, one of the answers is angle 11. But what if we look down here? And I can shrink this, and I'm going to cover up this. My new line is this line. And again, the transversal comes down. I'm going to just look at the group 1, 2, 3, 4 and match it up with the group 17, 18, 19, and 20. So angle 1 is in the upper left corner. I go down here and I find that angle 17 is also in the upper right corner. Angle 17. All right, let's move that one down and let's take a look at the upper left corner. Now our lines are going to change. That becomes my transversal. My new lines are the two diagonals, here and here. So you've got two lines. My transversal comes along through. Which one matches up with 1? Well, again, it's got to be above the transversal, above the green, to the left of the red. So above the green to the left of the red, that's angle 5. And so we can add angle 5 to that list. Now let me clear everything out and let's see if there's anything else that we can do. We've already covered this section, so we're not going to use that one again. We've done one from here and we've done one from here. Is there a corresponding angle down in the group 13, 14, 15, 16? Well, No, there's not, because we don't have a transversal that takes us from the top group to the bottom group. See, there's not a single line that goes down and continues straight to get you down to that group. So there is no corresponding angle from this group down to this group because there's no transversal that carries us. All right, for all of the other examples, we had a transversal. I could go from this group and I could follow that transversal straight to it. And I could take from, again, this group, and I could go straight down to there. And then finally with my last one, I had a group here, and I went straight down to here. All right, there is no way to go from this top group straight down to this group. And so therefore, there's not a relationship there. We don't know anything about those angles. We're not going to try and compare angle 1 to angle 13. All right, thank you.